of change and tangent lines. So when you hear the word find the average rate of change on the AP test, those words mean to find the slope. Okay, so let's draw a little picture of this. Okay, so if you look in the book, I get a lot of these examples out of the book, but this is days. This is the number of fruit flies. And like 150 to 340, and the days is 23 to 45. And the title of this, you should always give a title: Fruit Fly Population. And it looks something like that. So 23 150, I'm going to put a dot. It's supposed to be, I'm going to make it nice and big so you can tell it's at 23 150, and the other one's going to be at 450 and 340. Okay, if we want to find the slope between those 2 points, you guys, I can draw a line. And we're going to find the slope between those 2 points, and that is called the secant line. The slope between those 2 points. And we're just going to, it's y minus y over x minus x, right? And obviously the 340 and the 150 are the y's, and the x's are the 45 and the 23. So you get, what do we get? We get 340 minus 150 are the y's, divided by 45, take away 23. And 340 take away 150 is equal to 190. And 45 take away 23 is 22. And I did not simplify it. I don't know if the book simplified it, but I didn't simplify it. 2 goes into both of those.
95.
Yeah, 95 and 11, right?
Yeah.
Okay, now we're going to do basically the same thing in part 1 that we just did in that little picture. So in part 1, f of x is equal to x cubed minus x, and it's over the interval between 1 and 3. That's the interval. They ask you to find the rate of change. And when you hear the word rate of change, you're going to say, that's right, they want us to find the slope. What I would do, this is the interval between 1 and 3. Those are really your x values, correct? You need to still find your y values, and you have a formula to find the y value. It's x cubed minus x. This is between 1 and 3. When x is 1, you get 0. When x is 3, you get 27 minus 3 is 24. So if they ask you to find the rate of change over the interval of 1 to 3, if I were you, I'd make an ordered pair, and then now you just have to do y minus y over x minus x. 24 take away 0, divided by 3, take away 1. 24 take away 2, which is equal to 12. So that's an easy one. I'm just going to let you know, they might give you a tangent one. I know they're going to give you a sine or a cosine or a tangent one. I just remembered this from the book. Like they might ask you to do f of x equal to the sine of theta, and they might say over the interval of pi over 2 to pi. Again, this trig comes randomly throughout the rest of the book, and you have to know how to do this without a calculator throughout the rest of the book, and that's why you needed to take trig. Well, if this is the interval from 90 degrees to 180, I'm hoping you guys know that. In a calculus book, we do radians, we don't do degrees, but all you would have to do is, I know one x value is pi over 2, and another x value is pi. Isn't this the formula to find the y value? So you need to know what's the sine at pi over 2. Without a calculator, the sine of pi over 2, well, that's 90, that's 0, 1, correct? The sine is the second number, which is a 1. And what's the sine at pi? Isn't that negative 1, 0? And isn't the sine at pi 0? Could you still do y minus y over x minus x? I never did this before. In all my years, I've never showed them a trig one. I just remember this now, that it's in the book, and you're expected, trig functions come into play constantly throughout this book. So they're just making sure you guys remember how to find them, and I'm not going to finish it, but you could do y minus y over x minus x. Or what the heck, let's finish. We're almost there anyway. 0 take away 1 are on the y's. A pi take away a pi over 2. Well, 1 full pi take away a half a pi is still going to give you a half a pi. And 0 minus 1 is a negative 1. A negative 1 divided by pi over 2, though, the book would have a negative 2 over pi. The book would have a negative 2 over pi. Because you would flip it, if you know what I'm talking about. So there's a nice little taste of what trig is going to look like in this book throughout the year. They're not going to ask you to find the sine of 63 degrees or the sine of 22 degrees. They're going to ask you to find the sine of 30 and the 30, the 60, the 45s, the 90s. That's all they're going to ask you throughout this book. So, okay, I think we're done with that page. Okay, now comes the tangent to a curve. What's the difference between the rate of change or the secant line and the tangent to a curve? Let's put the secant line up here too, so you know the difference between these two. Instead of using numbers, the book explains what a derivative is using a variable. So this is some x, and this is some x plus h farther along. In the last problem, it was 23 days and 45 days, but this is the definition of a derivative, so I'm showing you what a calculus teacher in college would show you, an x and an x plus h. And then up here, this is f of x, and this is an f of x plus h, again farther up on the y-axis. And I'm just going to draw a shape from this dot to this dot, just like I did in the last problem. It's just a different shape. I'm going to make a shape like that. Okay, so if I asked you to find the rate of change, which is the slope, let's write that down. Rate of change, which is equal to the slope, which is equal to the secant line. Correct? We talked about all of this. The rate of change is another name for slope. Another name for slope is if I drew a secant line from one dot to the other dot. That is the secant line, correct? So if I asked you to find the slope of that secant line, it looks like this. The second y is f of x plus h minus the first y, which is f of x. We're doing the exact same thing that we did on the last page, except instead of numbers, this is the formal formula for a derivative right now that you would see in any calculus book. These are your x values, the second one minus the first one. Which simplifies to, I don't want to rewrite it. The x and the negative x cancel each other out on the bottom. So it's like that. F of x plus h minus f of x all over h. Boy, you're going to see this for the next 3 sections. F of x plus h minus f of x all over h. That is the formula for the slope or the secant line, correct? Now, we are going to add the tangent line on here now. The tangent line is f of x plus h minus f of x all over h as the limit as h approaches 0. By putting the limit out in front, we just changed it from the secant line to the tangent line. And that is the definition of a derivative right there. The limit as h approaches 0, f of x plus h minus f of x all over h, which is the tangent line that is going to be parallel to the secant line on this curve. I mean, would you put that tangent line right here? Would you put it right here? Or would you put it more right here? Right there. So it's the tangent line, it's going to be like right here. But it might be there to be parallel. It might be here. It might be here. So basically, this formula is to put any tangent line on this curve. What kind of a tangent line is this? This one's a positive one. This one might be a little, this one still would be positive but steeper. This would be positive but flatter, right? So this formula will place a tangent line anywhere on this curve, and it'll tell you exactly what the slope is of that tangent line. You know what I'm talking about? So this right here is going to give you the slope of the tangent line. This will give you the slope of the tangent line. So, okay, we are done with this page. And here are some examples now. I'm not going to start with the fraction one because that's difficult. I'm not going to start with this one first because this one's difficult. Ooh, maybe I have to. Okay, we'll start with this one. You know what? I'm not going to start with this one. I want to add a new page, and let's do a different one.
What page is
F of x is equal to 2x plus 2. Find a form for a. It's going to say find a formula for the slope at x equals a, and where does this? I'm just going to say where a is equal to. I'll add to it whenever I'll just add to it when we get to it. Find a formula. That's really bad handwriting. Find a formula for the slope at x equals a, and I'll tell you what a is after I get done, because I just made this problem up. So you're going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. We're going to start with a very basic one this year. I added this, so you have to find some extra room, which I know you can find some extra room. You could put it on, the bottom of this page easily, or wherever you want to put it. Okay, you will get deducted off on the test if you don't keep putting the limit as h approaches 0, because that changes it from the secant line to the tangent line, the limit as h approaches 0. If you took calculus not to take corners, you've got to do everything, you've got to make shortcuts. You cannot do shortcuts in calculus. You have to keep doing the limit as h approaches 0. Okay, here we go. It used to be f of x, correct? It's now going to be f of x plus h. That means in place of all the x's, it's not going to be an x. What is it going to be? X plus h. So you're going to put a 2 down, but in place of x, you're going to put an x plus h. You're going to put another plus 2 down. So this f of x plus h is going to be 2 parentheses x plus h plus 2. So far so good? Minus f of x, and doesn't f of x equal 2x plus 2? And I'm going to put that in parentheses, 2x plus 2, all over h. Anybody take physics last year? You're the only one? Okay. Okay, then the limit as h approaches 0, and now we're just going to simplify this. You're going to get 2x plus 2h plus 2 minus 2x minus 2 all over h. Everybody follow that one? The 2x and the negative 2x cancel each other out. The 2 and the negative 2 cancel each other out. And you know you're doing a calculus problem right and finding the derivative if everything left on the top has an h on it. This is a very basic one. It only had, what, 2x plus 2 up there. So the h's cancel each other out. Not yet. I want to explain something. In limits, you were supposed to substitute in place of the h's a 0, but you can't right now because it would be undefined, correct? Everybody understand why you cannot replace the h for 0 here from the beginning, because it would be undefined. That's why we're doing all this work. I can take out the h, so the limit as h approaches 0, you're just going to be left with 2. What is the limit as h approaches 0 if your f of x value is a 2? If you think about it, f of x equals 2 is really a horizontal line at 2, correct? Everywhere the slope is going to be what in this answer? 2. You don't even have an h to put the 0 in, it just ends up being 2. So I'll talk about b later. This one's too easy of a problem where I can't even solve for x in this problem. So what is the slope everywhere on this graph? Well, it makes sense. This is 2x plus 2. You put your first dot at 2 and you go up 2 and over 1. Doesn't this make a line at 2x plus 2? What is the slope at a equals 3? Well, the slope is 2. What's the slope at a equals 4? 2. What's the slope at a equals a negative 3? 2. The slope is 2 everywhere on this problem, right? Isn't the slope 2 everywhere on this problem? Okay, now it's going to change on the next problem. And here we go, a fraction one. Calculus in college, they even give you radicals. I'm not going to give you a radical until we learn a different form in chapter 3. You're supposed to find a formula for the slope at x equals a, which means that, I'll explain that later. And where does the slope equal a negative 1/4? So I'm going to tell you what this stands for at the end. So we're supposed to find a formula for the slope at x equals a. That means anywhere on the graph is what x equals a means. Everybody understand that? Where does the slope equal a negative 1/4 on this graph? So here we go. We're going to do the limit as h approaches 0, f of x plus h minus f of x all over h. And this is the derivative formula in calculus. So here we go, the limit as h approaches 0. It means in place of all of the x's, what are you going to replace the x with in the first one if it's f of x plus h? X plus h, right? So isn't it going to say 1 over x plus h, right? 1 over x plus h minus, because in place of all the x's you have to put x plus h, minus what f of x is, which is 1 over x, which is still all over h. This takes about 1, 2, 3, 4, 5, 6 steps in order to simplify this problem. Now comes the algebra skills. The calculus is the limit as h approaches 0 and setting this up. Now we're back to algebra. The limit as h approaches 0, the common denominator in the numerator is an x and an x plus h. An x and an x plus h. The common denominator is an x and an x plus h. I look at the old denominator and the new denominator, and the difference between that is an x. And the difference between this one is an x plus h. And I put that in parentheses because you have a minus sign, which means you have to take the opposite of both of them. I would definitely put it in parentheses. The next move is the limit. Some kids on the test just draw an arrow down. Nope, that doesn't fly with me. You cannot just put the limit as h approaches 0 and draw an arrow down. Like this is, or ditto, ditto, ditto. Nope. Your professors in college would not like that. It's going to be x plus h on the denominator of the numerator, right? And you're going to have an x minus x, everybody see that? Which cancels out. X minus x cancels out. We're going to have a negative h on the top of that. Then, as the limit as h approaches 0, you're going to have a negative h over x plus h. This is really h over 1, right? Change the division sign to multiplication and flip it to 1 over h, which is the limit as h approaches 0. The h's in the numerator and the h in the denominator cancel each other out. You're left with a negative 1 over x plus h. A negative 1 over x plus h. Once it's simplified, and you couldn't plug h, the 0 in for h up here or here or here or here. Everybody knows why. We can't plug the 0 in for h because it's undefined. I finally simplified it. I can plug the 0 in here, and this is going to be just an x here, a negative 1 over x squared. What's the limit as h approaches 0 of a negative 1 over x plus h? It equals a negative 1 over x squared. This is the formula to find the slope of the tangent line everywhere on the graph. This is the formula to find the slope of the tangent line anywhere on this graph. Another name for this is the derivative. That's the derivative. A negative 1 over x squared is the derivative. It's a formula to find the slope of the tangent line. So, what this means is find a formula to find the slope at x equals a. That means everywhere. That's the formula to find it everywhere. At x equals 2, x equals 3. We don't know what a is, but we can change it to a 1 or a 2 or a 3 or a half or whatever we want it to. Where does the slope equal a negative 1/4 on this graph? Where does the slope equal a negative 1/4 on this graph? Well, this is the formula to find the slope everywhere on the graph, right? So in B, all I do is take a negative 1 over x squared and set it to equal to the negative 1/4. Cross multiply, I get 4 equals x squared. Kristen already knew that it was 2 already. Square root. X equals, almost right. Whenever you square root both sides, you need a plus or minus 2. So it's not just that 2, it's also that has a slope of a negative 1/4 at a negative 2. And I'm going to show you proof that I know what I'm talking about. This is the graph of 1 over x. That's the graph of 1 over x, correct? at x equals a positive 2 and a negative 2, which is right here, I'm going to make a tangent line. At a negative 2, I'm going to make another tangent line. Do you see that these two pretty much have the same tangent line slope? And the slope is a negative 1/4. Do they look like they have a negative slope? They both have a slope of what? Negative 1/4. Where? At positive and negative 2. What about at 1 and, or negative 1 and 1, what kind of a slope does it have? A steeper slope, right? And what about at 4? What kind of a slope does it have? A flatter slope, correct? Everybody get that? Okay, next problem. We did that, we did that, we did that. Okay, we are doing this again. We're going to get better and better and better at doing what is the normal to a curve and what is tangent to a curve. The normal line is the line perpendicular to the tangent line. The normal line, so instead of saying it's perpendicular in calculus, we don't say perpendicular, we say that it is what? Normal. Yeah, so we are going to do this again. We're going to find the tangent line. We haven't found the tangent line. We only found the slope of the tangent line. And then we're going to find the normal line. So here we go again. And these are getting a little bit tougher. We have a 4 minus x squared. And now I'm specifically telling you where. It's not just x equals a. I'm telling you it's x equals 1 finally. So, ready to go? So here we go. You're supposed to find the tangent line. Find the tangent line. So in order to do that, we need to find the slope of the tangent line. We need to find a formula to find the slope of the tangent line, correct? And what is that name? The formula to find the slope of a tangent line, another name for that is derivative. Whoops, I spelled that wrong. The formula to find the slope of a tangent line is called a derivative. You need to derive to survive in the rest of this class. I know. You need to derive to survive. So, okay, you ready to find the derivative, which is the formula to find the slope of the tangent line. And here we go. Get better. You're going to get good at this. The limit as h approaches 0 of f of x plus h minus f of x all over h. We have about 20 minutes. And it's over and over and over again. So the more I do these, the better you get at these. So we got to get cruising because I'm just going to keep doing more and more of this and you'll get better. The limit as h approaches 0, in place of all the x's, you're going to put a what there? No, you're going to put an x plus h. F of x plus h. You got to come up with the formula before you can plug x equals 1 in, right?
Yeah.
Yeah, you have to come up with your formula first. So 4 minus x plus h squared. Everybody follow that? 4 minus x plus h squared minus, what's f of x? F of x is what? Don't you have to put that in parentheses or else you're going to get your signs mixed up? All over h. The limit as h approaches 0. Are you ready for this part now? What I just did over there on the board? Are you guys ready? Here we go. 4. Everybody knows where the 4 came from.
Forgot that part.
Okay, this is x squared, right? But it's going to be a negative x squared. If you multiply this together, it's going to be 2xh's, but it's going to be a negative 2xh's. And you know that this is h squared, but it's going to be a negative h squared minus 4 plus x squared. Finally, Miss Chose, can I skip some steps? Now you are skipping steps because you know how long this problem is going to take us? If you want to show all the x plus h times x plus h, you sure can do that. But this problem is gonna take a long time if you don't, they're expecting professors in college for you to think that fast at this level. So goodbye to the 4s, goodbye to the negative x squares and the positive x squared. Miss Cho said I'm doing it right if I have h's left on the top. How are we doing? Is there an h attached to each term? So I know I'm doing the derivative right. The limit as h approaches 0. Can I take an h out of all three terms? You're going to be left with a negative 2x minus h. Okay, all over 1, but I'm not going to put the all over 1. A negative 2x minus h. I couldn't plug 0 in until now, couldn't I? Right? So when I plug 0 in, what am I going to get? Negative 2x. What does that mean, you guys? This is the formula to find the slope at every spot on this graph. This graph is, what is it, 4 minus x squared, upside down parabola, right? That is the formula to find the slope everywhere, but we specifically want to find it where? At x equals 1? At x equals 1, the slope equals what? What does the slope equal? A negative 2. The slope at x equals 1 has a negative slope. It has a negative slope of a negative 2, but we're not even close to being done. We found the slope. They want you to find the what? Well, they want you to find the tangent line. They want the actual line. So what we have to do is the y minus y equals mx minus x. And what do you know where you got that from? The x minus x would be down here, and it's really the slope, y minus y over x minus x. It's called the point. You need a point and the slope in order to do this. Well, we know that the slope is a negative 2, correct? And we know the x is what? 1. Okay, we need to come up with the y value. Where do we come up with the y value? What does y equal, you guys? Yep. Y equals 4 minus x squared. And if x equals 1, what does the y equal? 3. Yeah. Oh my, right here. Y minus 3 equals a negative 2x plus 2. Y equals a negative 2x plus 5. Y is equal to a negative 2x plus 5. That's the tangent line, that's the A. Look at how much work you had to do. You had to come up with the formula first, and now this is the A. This is the tangent line. The next one is the what line? The normal line. I think on the first test, didn't you have a parallel and a perpendicular question? Wasn't it like problem number 1? This is the parallel and perpendicular. This is the parallel one, the negative 2x plus 5. Now we're doing the perpendicular one, which is the normal, right? So it's the same concept that we had in chapter 1. You're going to do y minus 3 equals something x minus 1, and the normal changes to a slope of 1/2, right? They have to be opposite reciprocals of each other. So you're going to get y equals 1/2 of an x minus 1/2. Minus 1/2 and add 3 makes 2.5. Final answer. We have 12 minutes. And what do we have here? I'm not worried about this. I was going to show you that movie, but we don't have time, and I'm not worried about this. Yeah, we just don't have time. Wow. Same concept. If f of x equals x squared, find the slope at x equals a negative 2, find the equation of the tangent line, find the equation of the normal line, draw and show. That's pretty much the exact same problem that we just did. So I wanted maybe do that one, and maybe, I mean, there's a lot, yeah. Do you wanna do that one? I can make it, we can make it like x squared plus 3 instead of just x squared. Should we do another one?
Like, just do that? Okay. I don't care.
Should we not find the equation of a tangent line or normal line, but we can at least come up with the derivative? Let's do the derivative, and then we'll move on to the next problem. How's
So
that?
the normal line is the reciprocal, so.
Negative reciprocal,
okay.
perpendicular,
Normal line
negative
is
reciprocal.
perpendicular.
Yeah,
Okay.
the normal line is the perpendicular, yeah. Let's just do it. The limit as, you know what, let's change this completely. Let's make it 3x squared minus 1. Let's change this completely. 3x squared minus 1. This will be a good one. Okay, ready to go? The limit as h approaches 0. F of x plus h minus f of x all over h. The limit as h approaches 0. We still got 10 minutes, so you guys ready to go? Okay, here we go. So, in place of all the x's, what are you gonna put in place of all the x's? Ooh, let's even go more. Let's make it a little bit more. Let's go plus x minus 1. Let's do that one.
Delicious.
Okay, 3x squared plus x minus 1. Where are you gonna go farther? Now you're gonna get into what calculus looks like. Look at that. Make my mind long. Okay, ready? In place of all the x's, what are you gonna put in place of all the x's?
Oh, yikes.
X plus h? So it's gonna be 3 parentheses x plus h squared plus x plus h minus 1. Did you follow all that?
Yep.
Okay, minus what f of x stands for. What does f of x stand for? Those three things right up on top. I put them in parentheses. Oh, this is way better than what I was gonna give you. Yeah,
Way better means way larger.
way larger, yeah. You guys ready to go?
Yeah.
Okay,
Oh, yeah.
this is 3x squared plus, isn't that 2xh's? 2xh's times 3 is 6xh's plus h squared, which is 3h squared. Last year they were yelling at me, what the heck, how'd you get 3x squared to 6xh plus 3h squared? You gotta think, the professor would have been down here
Yeah.
already finished by now, but that's okay. Plus x plus h minus 1 minus 3x squared minus x plus 1 all over h. You should be able to find the derivative of any function by doing f of x plus h minus f of x all over h, of any function that you studied in algebra. So, the 3x squares are gone. The negative 1 and the positive 1 are gone. The x and the negative x are gone. I know I did it right if all of my terms have an h in common with each other, so I know I did it right. I can take an h out of all the terms and I get 6x plus 3h. 6x plus 3h as h approaches 0, correct? As h approaches 0. So what's the derivative? What's the slope? What's the formula to find the slope of the tangent line?
6h.
6x.
6x.
Yes. That's the derivative. It's the formula to find the slope of the tangent line. Everybody see how we got 6x? Okay, and then what does it say to find it at what specific x value? X equals a negative 2. To do the tangent line then, what was it, -2? You're gonna have an x plus 2 here for the normal line. You're gonna have an x plus 2. You're gonna have a y and a y. These are very similar, right? The points are gonna be the same, the slopes are gonna be different. At a -2, isn't the slope gonna be a -12? And this one's gonna be a positive 1/12? Where in the heck are you gonna find the y point in this problem? It doesn't have a y, it doesn't tell you what the y is. You have to go all the way up to the top. And at a -2, a -2 times a -2 is 4, and 4 times 3 is 12. 12 take away 2, take away 1. 12 take away 2 is 10. 10 take away 1 is 9. That's what happens when you make up your own problems. You get a 9 for your y value. You know, on the AP test, if you leave it like this, they'll give you full credit. They don't even want you to simplify it, but you're so used to simplifying that you don't even know, like, you could stop right there if you want. I think the book simplifies it, so if you wanna check the answer, you would have to simplify it. But I'll give you credit if you leave it like that even, so, cause that's what the AP test does. I think you're in such a hurry, you got the concept down, that's not calculus, that's algebra, just simplifying something, so. Okay, we are done with that, we've made it definitely more challenging. At what point is the tangent line to f of x equal 3 minus 4x minus x squared horizontal? Okay, so we have 5 minutes, so basically you're gonna do the same thing. You're gonna put 3 minus 4 x plus h minus x plus h squared minus 3 plus 4x plus x squared all over h.
Yes.
So anyway, in place of all the x's, I put x plus h minus, I changed this to, and I changed this, and I already changed this to their opposites to go a little faster. The limit, as h approaches 0, of 3 minus 4x squared minus 8xh minus 4h squared minus x squared minus 2xh minus h squared minus 3 plus 4x plus x squared all over h. I'm just going fast because I've got one template to do. I've got one template to do, so I'm just going
speed it
fast.
up, just
3,
cross
3, 4. Well, I went with 4x squared. Where is he? There he is. Take out an h. You're gonna have a -8x, a -4h, and another -2x. I could have combined those two together. Couldn't I have? H approaches 0, you get a -10x. And at what point is the tangent line? So that's the formula, that's called the derivative. I went really fast. Did I do that right? I think I did. Yeah, I did it right. At what point is the tangent line horizontal? It doesn't say anything, but the slope of a horizontal line is equal to what? 0. So what you have to do, you would have to set that equal to 0, right? Which would be at exactly 0, right? So or wherever it would be, so I'm just making sure I get that right,
Well,
yeah.
it would be at 0, yeah.
Yeah,
Because h turns into 0 and then x
Yeah.
turns into 0, so,
yeah. Okay, last problem. I don't know if we're gonna finish, we have 3 minutes.
We have 3 minutes. and we have
Determine
to
whether the
finish.
curve has a tangent line at the indicated point. If it does, find the slope, and if it doesn't, explain it. So basically, maybe for notes tomorrow or maybe tonight, what you're gonna do is you're gonna find the derivative of that one on your own. Find the derivative of that one, and you're gonna, this is where it's kinda judged at 0, right? So you already know what your x value is, it's what? It's at 0. Determine whether the curve has a tangent line at the indicated point. And they don't say the indicated point, but you should know that you're working with 0 just because they both have a 0. If it does, find the slope, and if it doesn't, explain. What you're gonna do on your own tonight is find the derivative of this by doing the limit as h approaches 0 of f of x plus h. And you're gonna find the derivative of this one at 0 and the derivative of this one at 0 and see if they're exactly the same number or if they're totally two different numbers. See what I'm saying? You're gonna do exactly what you've been doing, except you're gonna do it twice because it's a piecewise graph. So now you can't just do it once, you have to do it twice. So